Hey, welcome back. It's Craig Beals, and we've been working our way through the mole here, and we're finally up to the point where we can start doing some converting. We're going to start with converting mass to atoms and atoms to mass. Now, in the last video, we talked a lot about molar mass, so if you don't understand the concepts of molar mass, make sure you take one step back. I'll put the link down here below me somewhere and down in the description so that you can play catch up if you need to. But when it comes to converting mass to atoms, there's a couple of conversion factors that you really need to take note of. And those are the following. The molar mass, which I just spoke about. The molar mass is the mass grams per mole. So typically that ends up being 1 mole and whatever the mass of that is. And we need to use our periodic table to find that. For example, if I was going to do 1 mole of hydrogen, the elemental hydrogen, it would be 1.01 grams. Now I can also put that as 1 mole of hydrogen over 1.01 grams of hydrogen. I should probably put my hydrogen up here. I apologize for the poor handwriting. But that's molar mass. Those are the two conversion factors we're going to need. The other one here is, of course, when we're talking about the mole, is Avogadro's number. Okay, so Avogadro's number, which is the mole, or represented as a mole. So if we have 1 mole of hydrogen, we'll go right back to hydrogen, we have 6.02 times 10 to the 23rd atoms of hydrogen. And likewise, we have 6.02 times 10 to the 23rd atoms of hydrogen in 1 mole of hydrogen. So you're going to see these conversion factors all the way through here. Let's start with our first example. I'm going to refer back to this all the time, and you've seen me do it the whole way through if you've been watching the videos. These are the easiest ways to work through these problems, and we call this dimensional analysis. First part says write down what you know, and what you know is what's given in the problem. In this case, it's 45 grams of mercury. Mercury is Hg. In dimensional analysis, we need to get rid of this grams of mercury because we want to know how many atoms. So right now we're stuck in grams of mercury. The only way to get into atoms is to get rid of those units of grams of mercury. So I'm going to put grams of mercury down here. And then the next part is the tricky part, figuring out, well, what do I put on top of the next conversion factor? Grams can only turn into one thing. It can only turn into moles. This is why we're learning about moles, because once we turn things into moles, we can turn it into anything we want. So I can put moles of mercury up here. Now remember, molar mass, mole and mass, mole and mass. This grams represents mass. Mole and mass is the molar mass. It is the mass of 1 mole of mercury. Where do I get that? From my periodic table. I find mercury on the periodic table. It's number 80, way down here. Hard to see that on yours, but I can see it on here very quickly, very clearly. It's 200.59 grams. So the molar mass is 200.59 grams per mole. Boy, I made a mess. These are going to cancel, and I'm left with moles of mercury. I don't want to be in moles of mercury when I get done. I want to be in atoms of mercury. So I need another conversion factor right here. And I'm trying to get rid of moles of mercury, so I'm going to put moles of mercury down here. It's the easiest thing to do, just so they'll cancel out. I can turn moles into anything I want. That's the beautiful thing about moles. I'm trying to get my answer over here in atoms of mercury, and I just said I can turn moles into anything I want, just about. So I can turn that into atoms of mercury. Now remember, when we're going from moles to atoms, there's only one conversion factor. That conversion factor is Avogadro's number, 6.02 times 10 to the 23rd. Anytime you see atoms like this, anytime you see atoms, you're going to have Avogadro's number in the front of it. Now let's take care of some accounting and get rid of the moles of mercury. These cancel because they're on opposite sides of the line. And the only units I have left right here are atoms of mercury. Well, that's what I want my answer in, so this has got to be correct. The only thing I have to do now, we've done number 2, and 1, is solve. I'm going to get out my trusty calculator for that. And here's the calculator. I'm going to clear that off from some math we were doing before. I'll walk you through this. Let's take 45 for the 45 grams times 1, but I'm going to skip that step because I don't need to do it. I'll go straight to divided by 200.59. I'm going to hit enter just so that the calculator can keep track of what's going on. Let me move this out of the way so we can see. Now I've got an answer for all of this, and I need to times that by Avogadro's number, 6.02 times 10 to the 23rd. So the calculator's keeping track. All I have to do is hit the times button. And now here's the part that people mess up all the time. They try to get fancy. Don't get fancy. We're trying to put this number in right here. 6, let me move this, 6.02 EE. The EE means times 10 to the. So EE, the last part, is 23. I hit enter. Here's my answer. I've got 1.35. Don't forget to look way over here. This E23 tells me times 10 to the 23. I'm going to move this down and write it right up here. We've got 1.35 times 10 to the 23rd equals 1.35 times 10 to the 23rd. And what are my only units left? Atoms of mercury. So there you go. There's our first answer. Nicely done. Let's try another one. How many atoms of sulfur in 2.12 grams of sulfur? Let's go right back to our rules. We write down what we know, and what we know is what we're given, or the one that has a number, and that's 2.12 grams of sulfur. There we go. We're trying to turn that over here into atoms of sulfur. So we start off with what we know, which is 2.12 grams of sulfur. In dimensional analysis, I need a conversion factor that has grams of sulfur down here on the bottom. Grams of sulfur, because I need these two to cancel out. That step's the easiest step. I don't want my answer in grams of sulfur, so I need to have grams of sulfur down here. The tricky part is remembering, what can I turn that into up here? Well, grams can only turn into one thing. They can turn into moles. That's why we're learning about moles. So grams can turn into moles. So I'm going to go ahead and put mole up here, moles of sulfur. And then whenever I see moles and grams, grams is mass, moles and mass, moles and mass, molar mass. That's the molar mass. So the mass of 1 mole is how many ever grams, or the atomic mass units of sulfur, which in this case is 32.07. 32.07. Take care of these units. Grams of sulfur is going to cancel right here. If I was to stop and get my calculator out, my answer would be in moles of sulfur. But I wanted in atoms of sulfur. So I need another conversion factor here in my dimensional analysis. I have moles of sulfur here. I'm going to put moles of sulfur down here. I can turn moles into anything I want. That's the great thing about moles. So if I've got it in moles, I can turn it into atoms of sulfur. Let's go ahead and put those units here. If you remember from the last slide, we said that 1 mole of sulfur is equal to Avogadro's number of sulfur. Anytime I have atoms here, I've got to have Avogadro's number, which is 6.02 times 10 to the 23rd atoms of sulfur. Cancel some units just so we make sure we're on the right track. Good. The only thing I have left is atoms of sulfur. Now, we're right down at this part. We set up our units. We already did that. We just need to solve it. The way we solve it is to get out our calculator. Here's the calculator with everything cleaned up. And I'm going to work my way right down through here. I've got 2.12 times 1, but I don't need to do the times 1. So I'm just going to do directly divided by 32.07, divided by 32.07. I'm going to hit enter just because this calculator doesn't keep track in sequence unless I use parentheses, but I don't need to. The next thing is I have to times that whole thing by Avogadro's number, 6.02 times 10 to the 23rd. I hit the times button. 6.02 EE means times 10 to the, then I just hit the 23. You can see this E means times 10 to the, and I hit enter. My answer now is going to be 3.98 times 10 to the 22. 3.98 times 10 to the 22. The only units I have left right here are atoms of sulfur, so I can put atoms of sulfur right here. That's my answer. I've got two examples to take this the other direction. So we're starting with the number of atoms and we're going to turn it into the mass. Nothing changes though. We write down what we know, and what we know is 3.50 times 10 to the 15th, 3.50 times 10 to the 15th atoms of helium. And as always, in dimensional analysis, when I'm converting moles, I need a conversion factor with atoms of helium on the bottom so that they cancel. Atoms of helium. I can only turn atoms into one thing. I can only turn atoms into moles of helium. Well, how do I do that? I have moles and I have atoms. If you remember from before, 1 mole is 6.02 times 10 to the 23rd atoms of helium. Avogadro's number, the 6.02 times 10 to the 23rd, is always going to be with that unit of atoms. I like to cancel things out right away just to see where I'm at and make sure I'm on the right track. Right now, if I stop and started doing my math, I would be in moles of helium, but I don't want to be in moles. I want to be in grams, or the mass. I need another conversion factor to get myself there. I can put moles of helium down here, moles of helium, and I can turn moles into anything I want, which means I can turn it into grams, or the mass. Grams of helium. How do I do that? I have moles and mass, moles and mass, moles and mass. That's the molar mass. It comes from the periodic table. I find helium right up here. Helium has got a mass of 4.00. That's what we're going to use. 4.00 grams of helium in 1 mole of helium. These units cancel. I'm in grams of helium, and that's what I want my answer in. All I have to do now is get out the calculator. We type this in, 3.50 times 10 to the, that's the EE button, 15. Then I need to take that times 1, which I'm going to skip, so I'm just going to go straight to divided by Avogadro's number, divided by 6.02 EE means times 10 to the 23rd. I hit enter, and here's what I get, but I still have some more work to do. I need to take this whole number times 4 grams times 4 equals, this is going to be scientific notation. We need to move this 1, 2, 3, 4, 5, 6, 7, 8. So we'll have 2.33. We're going to round this up. 2.33 times 10 to the negative 8. Here we go. 2.33 times 10 to the negative 8 grams of helium. In the next series of videos, we're going to convert moles of a compound into mass of that compound, and actually vice versa. We'll take the mass and we'll turn that into moles. We've got a couple more steps, but eventually we're going to end up where we can take mass of something and turn it into mass of something else by going through this concept of moles to get there. I will put the link to the next video right down here, and you get the link to the last couple videos popping up on the screen here, or you can come on over to bealsscience.com. I've got a whole series of videos that's going to help you out with chemistry, help you out with biology, or if you just like to watch stuff blow up and burn and bubble like I do, I've got a bunch of videos of that too. Keep on learning.